thank you so much for giving us a few minutes, some of your time. You probably remember Bill. He's the other co-founder of our Atheist and Christian Book Club. You've been kind enough to be a guest with us before. Bill and I and Daniel and all of Bill's Christian friends have been talking with him for years now, and he is going through what he told us is a existential crisis or crisis of faith that
It's
he
all because of you, Luke.
is his atheism is well it's not, I don't think all because of Luke, but it was your book that he's reread about several times now, and it keeps going back to it after the book club. And every time he has an errand to do, he takes your book with him and tries to read it again. And so he is thinking he understands it, and
Oh,
he is.
oh.
Um, you're understanding the point of it, but maybe not the details. Anyway, I won't put words in your mouth on that. He has some questions for you, Luke, and he's been wrestling with this for months now. And will we just sit back and take care of any technical problems? Or Bill, if you had a question for one of us, we're here for you too.
Well, by the way, Luke, how's the weather there in Australia?
It is a lovely sunny day.
All right.
Very nice.
I always like
I
to
know
ask.
last time I came at you with my guns loaded, so I'll try to be a little
Well,
bit.
I have to ask. I always have to ask Luke when I interview him. I think I've asked him this. Every question is just kind of funny every time we talk. I said, Luke, how is tomorrow looking?
It's looking good. I think you'll like it.
Yes. All right, Bill. The floor
Okay.
is yours.
Like they said, Luke, I've read several books, Return of the God Hypothesis by Stephen Meyer, who makes some points like you do about the complexity of the cell and so forth. But it was your book that's really started this crisis of faith, which is really concerning me. So let me just, Dan and I were just briefly discussing one of the things that has caused this crisis of faith, and that's the strong nuclear force. So my question would be, and remember, it's tough to articulate these questions when you don't know what you're talking about. So please bear with me. But you have the electromagnetic force where positive protons and negatively charged electrons attract each other. So first and foremost, what's the probability that we even have an electromagnetic force?
So it's actually one of the things that the fine-tuning argument tries to do is to say, all right, what can we meaningfully try to attach some probabilities to? We want to sort of work out, all this stuff. Like, what's the chances of this? It's kind of hard to think how to do that for theories themselves, if you get my meaning. So what's the probability of electromagnetism? That's kind of, I'm not sure how we get a handle on that. So what fine-tuning says is, well, look, there's the strength of the electromagnetic force. So for the sake of argument, maybe we should just assume there is an electromagnetic force. And let's say, what's the chances that you got it just right to have that atom? The problem is actually when it comes to the laws themselves, actually that's where you get symmetry principles and sort of some very deep mathematical ideas pointing you towards elegance and simplicity. Those sorts of explanations, they kind of work down at the level of the form, the shape, maybe not the existence. That's hard to get a handle on, but at least the form of the law. So the laws of electromagnetism are sort of remarkably beautiful and simple. So I hesitate to say that those are unlikely, although again, it's a bit hard to know what we mean by that question.
But here's what is on my mind: is you say by just chance or necessity you have the electromagnetic force, but then what's the probability that you'd have this strong nuclear force that holds the protons and neutrons on an atomic level? There doesn't seem to be a necessity to have both of those. Does that make any sense?
Yeah, that's certainly true. Well, it's very easy to write down, equations that would describe matter in a universe where there was only an electromagnetic force and no strong force at all. In fact, if you write out, it's the Lagrangian of the standard model, like the maths, right? It's all, this plus this plus this plus this. And all I got to do is I'll just delete a few of those, get your red pen out and cross a few of those terms out. And you have a perfectly good mathematical equation that describes the way things in the universe interact via electromagnetism, and there's no strong force, and so there's an electron will still go around one proton. You'll get a hydrogen atom, and that's it. That's your universe. So certainly there's nothing here looks like necessity. There's maybe simplicity, but that's a different thing. So there's nothing that sort of says it has to be this way. And again, I think that the question becomes a whole lot clearer once you say, all right, we've at least got these numbers, which is like, I turn this dial up and electromagnetism gets stronger or weaker, and I turn this one and the strong force gets stronger or weaker. What do I need to do where do I need to balance these two? And in order for something interesting to happen, and that's the sort of fine-tuning case. Actually, you got to kind of like, this one's got to be there, that one's got to be there, or at least there's got to be some sort of very careful relationship between the two. If you just spin both of the dials at random, you end up with, if the strong force is too strong, you burn. You make it too easy to make very heavy elements. So basically, everything in the universe would just be the most stable element. Which is, iron. So just a pure iron universe. If it's too light, then nothing will, if the strong force is too weak, then as you weaken it, you just start erasing the bottom end of the periodic table. And it doesn't take much before even carbon, which is a fairly small element, right? Only 6 protons, before it's unstable, and then you lose carbon chemistry and things get way too simple. So it's hard to get a handle on probabilities when you're just thinking in terms of the laws themselves. So we try to focus on these numbers because that gives us a bit of a handle.
So Luke, I know that when it comes down to these probability questions, Sean Carroll is making a big deal about brute facts lately. Like, we need to just stop asking these why questions. Is that going around now, that it was like, well, forget talking about these dials, we have them. That's just the way it is. End of story. Are you hearing that more and more? Is that
not so much more and more. There's a bit of that in what's behind me, the big picture.
Yes.
It's there somewhere. He's more, as I've heard him speak. Actually, I haven't heard him speak on this for a while, but his basic line was, look, if push comes to shove, we've always got the multiverse. Was more of his the first. There's a few other things he said as well, but that was his bottom line, rather than it just is.
Okay.
But I guess at some point, the whole point of naturalism, according to Sean, is at some point you say it just is. It could have been otherwise, as best we know, but for no reason it wasn't. So that's, I think the quote from Sean goes something along the lines of, "There's a chain of explanations that reaches the ultimate laws of nature and stops."
Okay,
Yeah.
so he pulls
So that leads me to the next question. You have this push-pull thing where you have the universe expanding because of dark energy, but yet you have all these trillions of stars, and that mass, that gravitation, I think you put it, is putting on the brakes to this expansion. So again, what's the chances that you would have this nice equilibrium? Is this making any sense to you?
Yeah. So, that's I think one of the best cases of fine tuning. It's just very, very clear. There's a number that describes our universe. We can go and measure it. It's a number we have to put into our equations. It's not predicted by those equations. We just have to go and look, the cosmological constant. When we go and measure it in our universe, for a long time we thought it was 0, but it actually turns out it's not 0 since the last 20 years. And there's a wide range of values that it could have had. And in fact, more than that, we have, if we wanted to explain it having a very, on this scale, sort of a large value, a value typical of the size of the possibilities, we'd find it really easy to explain that. There's various mechanisms that sort of contribute to this. There's all technical details, but we're not going to get into it. And then we say, okay, before I before I look at a universe, I tell you, look, here's the laws, and here's I'm not going to tell you the numbers. I made a universe in accordance with these laws, and I put one of these numbers in. If I picked at random over the range that this number could have, what happens? And the answer is, for the vast majority of the range, you don't get any structure. You get stuff, but it expands so fast or
Right.
collapses so quickly that nothing like a galaxy, let alone stars, planets, all that sort of stuff, forms. You either get a universe where, there's a proton every trillion light years all on its own, like just going, man, look, it's sitting there going, look, I could make a whole periodic table, but there's just no one around. Or you get a universe that just collapses in a second, which, stays a million degrees or whatever. It's just really easy to make those universes. So the question that we're trying to get at, I think, underneath this is there anything remarkable about all of this? I was reminded of this. Sorry, this is going to sound like a tangent. A very interesting book I read recently called "This Is Going to Hurt" by a junior doctor in the UK who became a comedy writer. So the book is in equal parts hilarious and just disturbing. But he has one of his case notes and just says, March 22nd, 30-year-old female appears in the hospital complaining of painless white spots on her tongue. Diagnosis: taste buds. So someone had come in and said, "Look, what are these?" And he had to say, "Look, no, those are supposed to be there." I think that's a great example of the sort of the question: is this normal? That we all want to know about. Like, is this normal? Right? All of this, right? All of this. We're in a universe that seems to do some pretty amazing stuff. Is this normal? Is it just any old universe, or is there something remarkable going on here that we should dig deeper on? And fine tuning tries to get a handle on that by saying, well, let's compare. If you go and compare your tongue with everyone else's tongue, you realize, oh, hang on, everyone's got these, so it's all right. If we go and compare our universe with a whole bunch of other universes and everyone's got life somewhere or something, then maybe this is just the kind of thing, trees and the dog and a planet and galaxies. Maybe that's just the kind of thing that happens. And it's not. We go and actually compare it to, at least in theory, all these other possible ways the universe could have been. And there's something pretty amazing going on around here.
So that's James and I, when we did talks, we would do a 5-minute clip with Sean Carroll, and he's agreeing with what you're saying, that this is terribly precise, this cosmological constant. So another thing, and so when both of you agree, then I'm starting to really ask questions and question my atheism. But another thing that James and I talked about is you have a sun where you have the thermal explosions pushing up, and then you have the gravitational push of the mass of the star. Yeah. So how unlikely, or how fine, they say it's on a knife's edge, this equilibrium. How do you articulate this?
Not quite. So that's an example of if you get the laws right to start with, then like our universe obviously doesn't have a problem making stars, right? It's all working very nicely out there. As long as you get the numbers right underneath, the universe can then play out and make these structures in a way where, you make some big stars and some small stars, just a collapsing gas cloud. It'll all come together really nicely. So within a star, within the sun, the very nice thing is, actually, thanks to the laws being right, it's a stable system, precisely because, yes, there's a balance there, but it's not an unstable balance. It's a stable one. So the classic example here is you draw, hang on, let me get my, draw a hill that looks like this, right? And you say, look, there's 2 places there you could balance a ball, right? I could stick one there, I could stick it there. Right. That one, they're both equilibrium because all the forces cancel out. Force up, force down, no force left or right. The problem with that one is if I go a millimeter to the whatever that is on your screen, left or right, if I go a millimeter that way, the ball keeps going that way. It's an unstable equilibrium. In other words, if I move away from it, I get pushed further and further away from it. Whereas this one, if I move a millimeter this way, I get pushed back in the same direction. In the opposite direction. Sorry, that's the whole point. The sun is one of those stable equilibriums. If it collapses a little bit, the nuclear reactions will fire up a bit more and it'll go back to where it was. If it expands a little bit, it'll cool off, the reactions will slow down and it'll go back to where it was. So it's the sort of fine tuning is not at that sort of level. It's not, every star in our universe isn't on a knife's edge of if this thing moves half an inch, the whole thing will blow. It's the laws underneath them, right? So it's quite easy to make a set of laws where this stable equilibrium doesn't happen. For very big stars in our universe, they're above a certain point, they end up being that one, the unstable equilibrium. If they expand a little bit, it's actually not quite this. They'll overreact. It's hard to sort of model that on just a slope. So if you push it this way, it'll go back, but then it'll just sort of oscillate out and blow itself up. This is why we don't see very big stars in our universe. It's quite easy to get a set of laws of nature if you make gravity stronger, where every star's like that. Anything big enough to burn is big enough to blow itself apart. And so that's the sort of that's fine tuning. That's not at the level of does a star work, but have I got the right conditions that stars can work at all? That's where the fine tuning kicks in.
And is it any more difficult that they have billions of these stars? I mean, that have to have these laws just right in this.
Well, again, if the laws are right everywhere in the universe, then everywhere's got the right stuff for life.
Gotcha.
Yeah.
So, but why would God make so many stars? What's the point when we're the center of things, supposedly?
Well, I don't think the Bible teaches that we're the center of things. We're the center of the attention of the Bible, but fair enough. It's for us, right? So it's funny how old these questions are. There's a really great book on this by Thomas Chalmers, which was written in 1812, which basically says, look, it's no part of Christianity that we're the only reason for the universe. We're certainly our reason, right? Things are set up so that embodied life can exist, and, here we are. But, could there be life elsewhere, he asked. And he says, well, we wouldn't expect the Bible to say. It doesn't. And God can do what he likes. So I think there's for me, why is the universe so big? There is a running theme through the Bible that bad things happen when human beings put themselves where God is supposed to be. That's a real running theme of, especially like there's a whole book of Judges where everything that goes wrong is that, like Romans, it's all there. So I think, why make a universe that's so big? You won't confuse yourself. If you think about the size of the universe, you won't pretend that you're the creator of all of space and time. If you realize how small you are, it's one way of putting us in our place as not God, which is for the first fact about our place that we need to get a handle on. That's my amateur theology kicking. I'm sure the others have some.
Hey, Luke, what about this analogy? I've used this before, and now that you're talking about this, I wonder if it's good or not. So if you have the tallest skyscraper in the world, which is the Burj Dubai, the Burj Khalifa, which is like half a mile, it's super tall. You've seen it. And if they just wanted to house people, that thing is a little excessive. I mean, if it was just for shelter. Yeah. So you have to ask, what was the primary purpose of the tower? Just for occupancy? No, I mean, you could have built a much less lavish building if occupancy was your chief goal. But obviously, the chief end of building that tower was the glory of the United Arab Emirates. And look what we can do. kind of, in a sense, that it's the monarchy of that region and the glory of that kingdom that they stick this thing into the high rise of modern skyscrapers. And I think that's kind of where I think the Bible goes. That group of atheists asked me why. Same thing Bill did at our Atheist Book Club a couple of months ago. And they said, well, why do you think God made all this stuff? It just doesn't seem reasonable. I said, well, if God created the universe, he wasn't on a budget, right? This was not for us.
Yeah.
I mean, it's for, I mean, it is that Psalm 19, the heavens declare the glory of God. And what we're talking about is something incommensurate, something beyond our ability to fully and completely understand. You think that's a good analogy, or am I just playing stupid?
Yeah, I think
there?
that's all right. I mean, am I supposed to be in this building? I mean, you could point out that, oh, well, look, there's flat floors, and the door frames are all about my size. Bigger for some of us, and these sorts of things. And if someone then says, "Well, why is this thing so big?" Well, it's okay. It's for me to be in, but there's a bit more to it than that. I don't have to say the sole purpose for the building.
Right.
By the way, Luke, Dan has been very effectively preaching your gospel. He's went into the lion's den and tried to articulate what you're teaching. And one of the amazing things was the fine structure constant, which Dan said, Richard Feynman said physicists should put this on the board and worry. So as an atheist, should I be worried?
So be clear about what Feynman meant. What he meant was there's something right there in our equations which tells us that more explanation is available, even independently of whether it's fine-tuned or not. We want to do explanations in terms of beauty and simplicity and symmetry, and we want these sorts of things to come out of our equations. And then right in the middle of the equation, there's just a number, right? 1 over 137, roughly. It's not even quite that. It's just some number, right? What is that doing in there? And how can we find a way of, if you look at the extended quote, so Feynman says, we know how to measure it, but we don't know what we should be, programming into a computer, say, for that number to come out. We know how to get it out of an experiment, but not out of a prediction. So he's worried about it on that sort of level of that. It points to, if tomorrow someone comes along and says, here's my ultimate, beautiful, wonderful, simple, mathematically elegant law of nature that is better than the one we've currently got, and it predicts the exact value of the fine structure constant, then all the physicists go, oh, amazing, fantastic. Go to Stockholm and get your Nobel Prize. That's wonderful. The worry, it's not so much that, so that's the worry in terms of here is something left to be explained. The fine-tuning worry is, well, look, if we're taking stock of where we're at with what science is telling us about the universe, I can use these constants as a way of getting a handle on what else, is this normal, right? It's the sort of equivalent of going around and checking whether everyone has got those painless spots on their tongue. Is this the sort of thing that happens on every tongue, or is it just me? Is this normal? So that's where these sort of things overlap. So people sometimes accuse fine-tuning of putting a stop to science, right? And that's absolutely not what we're doing. Like, I would love someone to come along tomorrow and explain why that number has that value. And then, we start to look at that theory and see whether that theory is fine-tuned. So this is all a work in progress. That's fine. We're just taking stock of what science knows right now. And we can sort of use the best science we have to try and get a handle on, is this normal? And if better science turns up tomorrow, we'll use that to try and work out, is this normal? And there's no guarantee there'll be I guess there'd probably be the same answer, but there's no guarantees because we don't have it. Anyway, sorry, go on.
So if it's 4% larger or smaller, you don't get carbon formed, which is carbon's formed in the stars when helium and beryllium get together. Is that right?
Yeah, basically 3 heliums. So 2 of them make a beryllium, and then a third one makes carbon.
So right from the get-go, you might not get carbon if this thing isn't. Is that correct?
Yeah, absolutely. More than that, the limits on that, you just got to get the masses of all the pieces involved. So inside of protons there are quarks. You got to get the masses of those right. There's calculations, supercomputer calculations about how precise it's got to be, and you know, relative to the number in our universe, it's still 2 or 3%. So relative to the total range that it could be, it's some extraordinarily small number. That's an interesting case, just because there's a very interesting paper by Fred Adams, I should point out, where there's a couple of different ways you might make carbon. So there's the fine-tuned way we do it, and I think there's probably maybe one other fine-tuned way of doing it as well. So there's almost like 2 spots on the dial you could be at. So it's no part of fine-tuning that our universe is uniquely fine-tuning. It's just got a rare property. It's not that, you know, if I say there's something amazing about that hummingbird flying out there, I'm not saying that there's only one way of making a flying bird. I'm saying most ways of putting cells together don't fly.
And here's one of the challenges. I mean, Dan gave an excellent presentation, but when he said fine structure, it's like it just blew over everybody's head. Do you get this where they just look at you like, you know,
like it didn't mean anything at all? It's like, so what? That's just the way it is.
Do you get that? Or Luke, or you probably don't talk to the public that much, do you?
I do a fair bit. Sorry, I missed that.
What I'm saying is, these remarkable explanations and evidence don't seem to impress not only atheists, but I'll talk about the fine structure constant to Christians, and it just blows over their head.
Yeah, Daniel and has been asked to lead some of the Atheist Book Club, not our Atheist Christian Book Club, just atheists. And Bill was there, and he asked or shared about the fine structure. And they were like, it didn't phase them. They didn't really, I don't think, understand it. Maybe, I don't know.
No, it was like we don't need to explain this.
You don't know. This is a brute fact.
It's basically, they were basically all in the brute fact camp. It's like, so what? But it boils down to like, well, we're in this beautiful house. Who made this? Why is this here? It doesn't matter. You're living in the house, and if you weren't living in the house, you wouldn't be here to ask those questions about the house. But that doesn't explain the house. But that's kind of where it ended up. And I don't.
So, Luke,
that's
the atheists. Are they just denying this evidence? Don't care about this evidence? What is the problem with their responses to this?
What does Geraint say about all this?
Geraint takes this very seriously, so he defends the multiverse, which is a good sign for me if you're taking this thing seriously, right? I mean, we can, and then there's a conversation we had about the multiverse, but if you can see that that's something that is needed, then you've at least seen the problem. I think I don't want to sort of amateur psychoanalyze a whole bunch of people. One of the things I love about this topic is that it gets a response out of just about everybody, but they're convinced that they're right. So I once gave a talk to, there was a group called Skeptics in the Pub. They're in New Zealand. And there was a great moment where I presented just the science of it, like the first half of the book, and then said, you know, I've written this book. My co-author's an atheist, so we agree on all the science, and a professor of astrophysics, of course. Here's what I say about it. Here's what he says about it, you know. And then the room sort of started arguing with itself, which was really great to watch, because the questions started coming at me and then started going like a crossways to everyone, as everyone sort of thought they had their answer, but then they could see the problems with other people's answers. So no, he's not saying no. So that there's so many different responses to this. I think I've used this quote before, possibly in the club, but I think someone said this to Alistair McGrath once. He gave a talk about fine tuning, and someone just said, "I'm not religious, but something weird is going on here." Response to fine tuning. So I think there's a couple of things. One of them is like a knee-jerk reaction of, if the Christians are saying something, they're probably lying, or at least if the Christians are saying something about science, they don't know what they're talking about.
Yeah, that's what I get.
If the design argument has been debunked, I don't even need to look at it.
Yeah.
There's, the same sort of people who say things like intelligent design is creationism in a cheap tuxedo, which as a what I would call a sledge, what I think you would call trash talk, is a great bit of trash talk. But I think just there are these first knee-jerk reactions. So there's sort of stages of grief here, denial, bargaining. There's the sort of knee-jerk. The Christian said something about science got to be wrong, and then when I present the fine tuning, I can sort of break through that a little bit by saying, look, I co-wrote a book with an atheist. I can quote all the atheists you can eat to support the science here. So you got to do something about this. And then there's a knee jerk of, look, small probabilities don't mean anything. That's the way it is. And then some people get beyond that to say, look, I wouldn't accept that in anywhere else. And then I think you start looking at, okay, we better do something that increases the probability. And then the multiverse starts looking like a good option. But this is, it's far from linear. There's a whole bunch of other things people say.
Well, I just go with what the Bible says. It says they're suppressing the truth in unrighteousness. That's one of James' favorite sermons. Are atheists suppressing the truth?
Again, I don't want to do amateur sort of psychology here. I don't.
Okay.
I can't see inside people's heads.
Here's another thing. Did you watch the James Tour Professor Dave debate?
Oh, I couldn't do it.
James won't even.
I couldn't either.
Like how to not debate. But here's the thing. As biased as I was to Professor Dave, who I like, and Tour is just this highly strung, crazy person.
Yeah, I've met him. He's quite intense.
Yeah. I thought he had some excellent arguments that with the origin of life, if you can have too many chemicals which gum up the process. And they have to a lot of times use purified chemicals off the shelf where that wouldn't be available in early Earth. So, you talk about the layman's dilemma. This isn't your thing, the origin of life, or, but you do know chemistry and stuff. How likely is it that life would arose, by itself?
For me, it's given that I'm a physicist, and so I feel like I'm separate to that. I've almost got a heads I win, tails you lose strategy here of if it's extraordinarily unlikely, then you should be worried. But if it turns out that an electron's a point particle, right? It's a point with a charge and a spin, right? Quarks, another point, charge, spin, a couple of other properties. There's not much to them, right? The fundamental stuff of our universe isn't, anything particularly complicated. If that stuff, right, under gravity, which just says, that thing, everything's pulling on everything else, and quantum mechanics, which is just straight up weird. If you can throw that stuff into a universe, right, and a billion years later it starts flying, like, wow, I'll take that as like this. That's a super fine tuning argument. Like, it takes an amazing amount of fine tuning for there to be a periodic table at all. If then the periodic table starts making hummingbirds, holy moly, man. Like, that's an extra. So I sort of think if there is a physical process by which life forms and it's just purely natural and you can just stick it all there, and I can't even begin to imagine how that could be happening, but that's my lack of imagination. I'm not in this field. Who cares? That doesn't mean anything. But if there is, and give that to me for a bit and I'll see how finely tuned you've got to make all the constants of nature for that to happen. And the fine tuning argument's just going to have an absolute field day. It won't be sort of, you've got to be in here in order to get out of this huge range, in order to have any element in the periodic table. Now you've got to be here so that, when this particle in this RNA world gets in this small swamp, under this moon, under the right, cosmic rays, it'll form a replicating cell that turns into I just think even if it happened naturally, there's still an astonishing design argument to be made down at the level of fine tuning.
Well, that's what my dilemma is you've got to get the carbon, which is kind of a minor, because it's what, two or three supernova explosions to get the heavier elements, carbon, oxygen.
Yeah, there's a couple of other ways as well, planetary nebula, but yeah.
Okay, so that's
you don't actually need supernova to get carbon. You need to get things heavier than a sort of iron. I've been trying to explain the fine tuning argument recently as not so much a standalone argument, but as sort of something that happens a little bit further on in the conversation. Like, we see the world around us, and almost every human being who's ever existed has seen the amazing things in the natural world and thought, well, clearly someone's thought this through, right? I mean, there's some bits I don't understand, of course, but there's places where the order is just undeniable. And so then you think, well, what happens to that intuition in the light of science? And if you're fine sticking with that intuition on the thought that, look, science is just going to look even more closely and find it's even more closely, interconnected than we thought, then great. If you think, no, I'd actually like to know whether this sort of thing is the sort of thing that typically happens, you are led then to say, all right, well, what's life made out of? And is a hummingbird the sort of thing that any old matter could make? And that leads you to sort of towards the fine-tuning question of, well, let's make some other universes and see if they're interesting at all. So it's trying to work out whether at the end of all of that, it's not that I know all of physics. It's that my first impression of like the amazingness of nature has remained intact. There's actually nothing in science to call that into question, right? It looks well put together as far as we know all the way down. This is why fine tuning is such a weird thing, and why all these things are such a weird thing is, I think this is an exact quote from a paper on fine tuning by Freeman Dyson in like the 70s, really early. It said, looks for all the world like the universe knew we were coming. Like, there are things happening in the early universe so that things can happen later in the universe. But that's not the way sort of ordinary physical causality works. So even if there was some process that can step in to Darwin's warm pond and sort your left-handed from your right-handed, it's amazing that process is out there. It's going to require something remarkable and fine-tuned from the way our universe is set up.
Well, let's say you grant God and then you believe in progressive creationism, because obviously young Earth's out of the question. Because you believe the universe is millions of years old, 4.5 billion for the Earth, do you believe 13.7 billion for the universe?
Yeah, more or less.
Okay. So you have a prokaryotic cell, 3.5 billion years coming in existence. It takes 1 billion years to get a eukaryotic cell with a nucleus. Why in the world would God wait 1 billion years to find a nucleus? Did he just not, figure it out?
I'm reminded of the previous comment. An eternal being can't get bored, right? You know what I mean? It's a bit like, an omnipotent being can't waste its resources. It can't, there can't be a waste of space out there. And
it's
so
not on a budget.
He's not on a budget. That's what I was looking for.
Yeah.
He's not on no one's stop clock either.
Mm-hmm.
So why would it take that long? I think, fundamentally to me, even if I didn't have an answer to that, it would, these sorts of why this way rather than that way when God's involved, they do come into the calculation, right? So if I want to know why this particular, arrangement of things are on my whiteboard, right? The ink on my whiteboard looks like this. Why would someone write that on my whiteboard is a relevant question. But if the alternative explanation is that, a tornado came through here and took the lid off the pen and just banged it against the board, the fact that it says, call the NRMA, yes, those questions do affect our probabilities, but they also can be completely swamped if the alternative is just completely ridiculous. So why would God wait that long? I think it's, again, if part of the idea of this creation is to remind us that we're not the creator, to put ourselves very firmly in the created category, then making it way bigger than us will enforce that, and making it way older than us is going to do it as well. So I don't particularly have a problem with that. The other thing is there's, if there's a plan coming about, then there's timings in that plan as well. You've got to wait until oxidation events happen. This is the history of life. I don't know.
That's what G. Ross would say. Yeah, you need certain things to happen.
Yeah, and it's not that God had to do it that way. It's just that there is then a plan, like all the bits fit together. You could have done it differently. But if there's a sort of place for things, then it doesn't massively affect the probabilities.
Maybe you can try, Bill, to turn the question around. Why don't we spend 1 billion years on our next project?
Mm-hmm.
Well, we have some limitations here. We're all going to be dead in a few years. So we don't have that luxury. God's not limited like we are.
Right. But it's not only that. Let's say, would you classify yourself as a progressive creationist, Luke?
I'm not sure what that implies. I've sort of lost track of who's calling themselves what these days. It's open to me. So there are some people who think that something like the Cambrian explosion, for example.
That's what I was going to go to. I mean,
that obviously God just made some things at that point to kick evolution on a bit.
Yeah, that he has to go and jumpstart this with the
I'm not attracted by that at all. Really? I recently described it as God giving the earth a kick in the Precambrian. And I don't I'm not attracted to that theologically. I just think, that just,
But there was a Cambrian, the major phyla, the chordates, the echinoderms, all these phyla just suddenly appear. And it's one of the creationists and Christians' go-tos,
God likes trilobites and beetles.
Yeah.
I must admit, I'm reading Wonderful Life by Stephen Jay Gould, which is all about the Cambrian explosion. And I'm at the very interesting bit where he's just about to say how they realized what was really going on down there. That they spent, decades trying to push all of these fossils into existing categories, trilobite and trilobite-like. And then I'm just at the point where someone's about to go, you know what? These aren't trilobites. This is completely new stuff. So it's getting exciting. So I think my preference, like my theological preference, would be that God does the prep work for the universe back down in physics and cosmology, and everything else sort of works itself out after that. I think in the older terminology that would make me a theistic evolutionist. I don't like that term either, but I'm fine. If it turns out that God did some miracles at the start of the Cambrian explosion, then fine. It's available for me because I believe in God. And it doesn't seem to be a particularly elegant solution to me. But again, I'm not going to tell God what to do or not to do. I think there is something that it is a fact about our universe that there are some things that God has left us open to discover about it, and so throwing a miracle in would kind of shut that down. But again, these are some half-baked thoughts.
Well, it seems to me that Christian or atheist, you have to live with the tension. Cambrian explosion looks like God might be behind it, but then you have endogenous retroviruses where us and chimpanzees have like 211 out of 220 whatever places on our genome with these endogenous retroviruses in the same place. The probability of that happening by chance is remarkably low. So it does seem to indicate that us and chimps have a common ancestor. So can you live with the tension of these two different views?
Not really. So my preference is, and it's quite it's subjective, but my preference is that God made a universe that produced galaxies, stars, planets, life, intelligent life, and us entirely through natural processes. Meaning not that God took his hands off, but that the way that that came about is a way that can be described via, a rational plan, rational sort of laws, like the laws of nature. So it's not that it's naturalistic, not that it, any old universe, but that God, the way God did that is via processes that we can describe in rational, rule-like, law-like terms. So, I think the laws of nature just are the way that God runs the universe. He's running it so consistently and elegantly that when we go to describe it, we can describe it with very elegant and beautiful mathematics. But it's not a universe sort of moving on its own, separate from God. The laws of nature and the way God runs the universe just are the same thing. So in that case, there's not a hard line between laws of nature and miracles, except that, God has a usual way of doing things because God is rational, right? God's a mind. God, appreciates the value of simplicity, I suppose. So my preference would be that there is a rational way of understanding the way the universe works, in which the origin of life comes out through processes that we can understand rationally, rather than ones where there is just a break with the way nature usually works. Because where I see those sorts of events happening, the resurrection of Jesus of Nazareth is such a good example. There isn't a better one. There's no point making up an example. That's the perfect example. The whole point of making that break is precisely that makes an important point that God wants to make. That A, here is someone to listen to who's not just another voice. And B, there are things about this universe that are temporary, that will serve their time and then be done, right? Death will have served its time and served God's purpose. And then there's going to be a time when that's not the way God's going to run reality anymore. And the way of showing that is to say, look, I can override this. I'm in charge here. Here's a guy walking out of his own grave. But where there's not that sort of lesson to be learned, I can't see why God would stick his finger into the Cambrian, where he if the option is available for God to, via amazingly fine-tuned natural processes, to just do it using those sorts of processes.
Well, here the other problem is, let's say these are just, the Cambrian just comes about and God laid the underpinnings and so forth. Here's the problem is, then in the Permian extinction, he wipes out 95% of all life. In the KT, he goes with a meteor, just by happenstance, comes, and God can prevent it probably, but that wipes out all the dinosaurs and stuff. So my question is, why would God spend all of his time developing life just to extinguish it?
Yeah, so this is why I think a coherent, rational, natural order is a better explanation than God sticking the finger in. I think it's sufficient to that God is making beings who are in his image eventually. Like, God has the long view in mind, right? And so there's a question of why do it in a way where things are born and die before we even exist. Well, if they're part of that process that we can understand afterwards, the way God chooses to bring us about, then that's a reason for that to happen.